Thank you. So we just put it into the calculator, we square the number, and that gives us our value. Now, this allows us to analyze the two variables in closer detail. It gives us a bit more information about it, okay? So it says here, it's the degree to which one variable can be predicted from the other variable, okay? So that's determination. So how much of this determines the other, right? So the way that we interpret this, so we know how to calculate it. So if your R is 0.8 here, if you do R squared, that's 0.8, which is 64. Now, if we represent it as a decimal, then that's a proportion or fraction or a decimal. However, most of the time they want us, in our final answer in year 12, they want us to represent it as a percentage. Okay, so all you have to do is take that value and multiply it by 100. Or in other words, move the decimal place 2 spots to the right. Okay, that will give you a percentage. Now, what's useful to us is the percentage, because when we go to describe it, it makes more sense, okay? So it tells us the variation in the response variable. So the response is your vertical axis. Remember, R is your vertical, and E is your explanatory variable on the horizontal axis there. Now, we know that these numbers down here are quite stable, right? We show that they increase in a linear fashion. But then along those lines, we can have different values along it, okay? And you can see some sort of a trend going upwards or downwards. The response variable depends on the explanatory variable. But here we're saying that this changes possibly because of this value down here. So the variation, we're talking about variation, that's the key word. So variation is how much it changes. It can be. So you have to be very specific in the wording here. You have to be very careful. They say that is explained. No, we say that can be explained. Okay. VCAR, which is the people who will be writing your exams, and you'll be doing exams next year, they want this specific wording. Can be, not is, because we're not for sure. We're not absolutely certain. Okay? That's the thing about the real world. When we take a picture of the real world from data, you can never be sure, 100% sure. Okay? So you say it can be. We want to be we want to play on the safe side here. Okay? Like maybe, yeah? So in terms of an example here, if they say that there is a relationship between the weight and the height, so let's just say that the coefficient of determination is 0.64 or 64% as a percentage. The final statement is that the coefficient of determination tells us that 64% of the variation in the response variable, that's people's weights in this particular case. Once again, not is, but can be explained by the variation in their height. Okay? So one thing explains for another. So only 64% of the ideas. So weight definitely tells you your height, right? In this particular case. But what other things can dictate your height? What other things might affect your height?
Genetics,
Genetics, yeah. What else?
nutrition,
Nutrition, how much you eat.
Yeah.
What other lifestyle choices?
Physical activity.
Yep. So maybe exercise. So all these are other things can also be explained by the variation of height as well. Okay. Sorry. The variation in people's weights. Sorry. The variation in people's weights can also be explained by all these other things as well. So not 64% is only explained by the height. Okay. There are other things. And what we call these are confounding factors. So there are other things that might explain the variation. Okay.
We're still talking about weight here, yeah?
Yes. So these are the other percentages. These things might make up the other percentages. That adds up to 100%. But
Okay.
because this is bivariate data, we're only looking at two things, yeah? The relationship between two things. Obviously, other things affect it as well, but that's the thing. We're only looking at two things here. That's what this number tells us, how strongly they're related.
We also don't know whether somebody lied about their weight. They could have they might have read it wrong. They might have, oh, you know what, I might just reduce my weight by 5 kilos. We don't know exactly. There could be errors in there that we haven't accounted for.
True. So
a lot of us women will lie about this. You know that.
incorrect readings, yeah, that's so true. Yeah. So yeah, people when they put in their data, they might lie about their data as well because it might be on a survey. Yeah. So university studies, or when they do research in universities or in any kind of company or institution, they need to consider these values here or these ideas when they're running a study. Because some people can fake it. You know how like when you do a survey, you might just click average for everything or high for everything without even reading it. So that will definitely affect the data. Okay, so we never 100% sure. All right, so definitely something to keep in mind. Now, how do we apply this? What kind of questions can we be asked? So let's say we're being given this question here. For the relationship described, it says the coefficient of determination is 0.5210. So what we need to do, what's the coefficient of determination? Key word there. What would we label that as? Is that the coefficient of is R the coefficient of determination, or is R the correlation coefficient? Yeah, so force, thank you. It's R squared. And the way that Force typed it in the chat, she put R hat 2. So to get that hat there, I'm pretty sure you've found this on your keyboard already. It's Shift 6. Yeah. So R squared equals to 0.5210. So if we have R squared, it says determine. So there's our process. What are we determining? The value of the correlation coefficient R. So we want to find what R equals to. Yeah. So if we want to find the R value, we need to take the square over onto the other side. But remember, when we, tempting, when we take this square onto the other side, do we still keep it as a square? What's the opposite of a square?
Square root.
Correct. So the opposite of a square is a square root. So you can see in the next line here, from this line into the next line, the square has disappeared because we've moved it to the other side and it becomes a square root. Okay. If you want to type that in the chat, this is how you type square root. So keep an eye on the chat, SQRT. I may as well teach you how to write online notation as well. Okay? Because on the CAS, if you press SQRT, lol. If you press, if you type SQRT on the CAS, it will change and it will register it as a square root. Okay? So R hat 2, that's for squares, and SQRT, if you want to write it on the CAS, you know, or even if you type this in Google. So check it out. Open up a page for Google. SQRT 0.5210, and that is the square root. Okay. So picking up these little skills here, just learning for the fun of it. The more you know. Okay. So we found out that this square root is 0.7218. Are we happy with that answer though?
No.
Why not?
Doesn't it have to be a negative?
Yeah, well, you're on the right track, that's correct. So if I might
Because the
ask,
slope's going down. So
yeah, what are you looking at to see that it's going down?
if we look at the graph, we can see that it's on a negative trend.
Yes. So you can see the line here. If I was to draw a general line through it, you can see as we're going from left to right, we're actually going downwards. So this means that R is negative. Okay. The thing about when you square root something, you always have to write plus minus first. Okay. So you write plus minus, then in the next line, you filter it out to be a negative. Okay. And I like the way that I like to reason it is I say as scatter plot shows a negative association. Okay, instead of saying graph, we have a specific name for this. It's called a scatter plot. Okay, and you can write that all in one line. So 3 steps, yeah? Write out your information, rearrange it, making sure you have the plus minus, and then figuring out which one you have to take, a positive or a negative. Okay. I'm just going to chuck on focus mode here. So, no, actually, I remember you guys don't like focus mode. Just put a thumbs up or a thumbs down if you understand what goes on here. So in simple terms, you square root the coefficient of determination to get your correlation coefficient. So you square root the number, then you just have to figure out if it's positive or negative.
Yeah.
Yes, Matt?
Will we ever need to find out? So let's say they give us the correlation coefficient. Would they ever ask us to find the coefficient of determination?
Yes. So if you have r, you can also find r squared. Vice
Yeah.
versa, yeah? Yeah. Absolutely. All right. So this is exactly what you just asked, Matt.
Or carbon
So
monoxide. All right.
yeah, carbon monoxide levels in the air traffic and traffic volume are linearly related. It's already told us, yeah? So there's two things we're looking at here. We're looking at air volume and traffic volume. Oh, sorry, carbon monoxide levels in the air and the traffic volume. So what do you expect? Like, let's just imagine if there's more cars, do you expect there to be more carbon monoxide in the air, or do you reckon there's less carbon monoxide?
More cars, more carbon monoxide.
Yes, the fumes. So you can kind of already draw a trend line. Okay.
Fun fact: carbon monoxide kills you.
Yes, it's a silent killer.
Yeah.
All right. So we see here, is this the coefficient of determination or is that the correlation coefficient? They've just given us an
Correlation.
R value, yeah? Yes. So always good to kind of identify that, the difference between the two. Correlation. Correlation coefficient. Okay, because it's just the R value. We notice it's a positive, but what happens when you square it? Because it's asking us to determine the value of the coefficient of determination.
Yeah.
Okay, write it in, okay, there's a condition here, there's a circumstance. Write it in percentage terms. I'm just going to do this first and then bold it here. And we also have to do another thing. We also have to interpret as well. Okay, so there's two things we have to do here, or a couple actually. And there's also some preamble here as well. In this relationship, traffic volume is the explanatory variable. So traffic volume is E. What's our response variable?
So the explanatory variable is is traffic volume, and then the response variable would be the carbon monoxide levels in the air.
So you can see up here, those are our two main ideas. What I'm going to do is I'm going to just label them, just so it's easier to look at. I should write capital R, to be honest, and capital E. Just so that if I do write R here, it doesn't get mixed up with the correlation coefficient. Okay. So to determine the coefficient of determination, we need to find R squared. So that's 0.9. Well, you can chuck the positive in as well if you wanted to. Square it. And just looking at the bottom here, you can put it in your CAS, is 0.970. But as a percentage, right? I'm going to say R squared here. if we want a percentage without having to use the calculator, just move your decimal place 2 spots to the right. So this is 97.0%. Once you've got that, if you leave out the 0.0, that's fine, because here they didn't specify it, yeah? Maybe they will say 2 significant figures. And this is why it's good to have a look at some exam questions. 2 significant figures. Okay, so just revising, what is 2 significant figures again?
2 numbers.
Yep, 2 numbers that are, well, the first number that you start counting from has to be a non-zero, yeah? So you can see this first number here is a 9, so we start counting our significant figures now. That's our first significant figure. This is our second significant figure. If there's 2, then we're done. We don't need to write that 0.0. Okay?
0.0 just looks nice.
But if it said 3 significant figures, then we would have to include that 0.0. Does that make sense, Danny? Good question. Okay, so if it said 3 sig fig, then we would have to write 97.0. That's 3 significant figures now. All right. So let's have a look, read through again. Determine the value of the coefficient of determination. Yes, we did. Write it in percentage terms. Yes, we have. But then it says, and interpret. So we can go back up to the structure here. And see, this is why it's important for us to have notes ready. Okay, so with all these here, these ideas here, it's a good idea to put it into your knowledge book. So which one's ours? So if we follow our framework here, it says that the coefficient of determination, yeah? We don't have to write the whole word. We just need to write the value. So what I like to say is, this means that, and you can see like, yes, you can see like the model answer there. I like to do it a bit differently. If you have both of these model answers here, then it's just more for you to see and more for you to capture a better idea. This means that 97.0% tells us the variation tells us that the variation, now here it says in the response variable. We're not going to write the response variable. We know that the response variable is CO2 levels in the air. That the variation of CO2 levels in the air, remember the word, not is, but it has to be can be explained by the variation sorry, I shouldn't write of CO2. I should say the variation in CO2 levels can be explained by the variation in traffic volume. Can be explained by the variation in traffic volume. Okay. So when they ask us to interpret as well, we need to use this framework here. So can I just get a thumbs up or thumbs down if you know how to calculate the R-square value? 1, change it to a percentage, 2, and then interpret it, 3. Okay. Good, decent amount.
That's a pretty high percentage.
Yeah, which means that, well, we need the data to back it up, yeah, and where this study comes from. But yeah, cars release carbon monoxide out of their exhaust pipes. For sure, that's a fact.
Yes.
All right, so here again, same kind of idea. All right. So that is that pretty much sums up. That's the gist of it. Okay. Now you can see this can be part of a extended response question where we might tell you to find the R value. Like we'll get you to put in the data points. All right. We'll just give you a table full of data. We make you put in all the points into your CAS to find the R value. And then this could be a follow-up question about the coefficient of determination. In fact, if you have a look here, the homework is due by this evening. Not for this particular exercise, but for the previous ones, up to 7H. And if for those who are up to date, you can do exercise 7G. I'll put the questions up onto Compass. Okay. Data. So I had a look through some exam questions from VCAR, and I pulled some out. I haven't sent this to you yet because this can be part of our revision, okay? 7G, 7I, 7G, 7I we'll do tomorrow. 7G we've already covered. This one here is 3G, yeah? So I'll just have a look. There's only 3 parts here. And look, you'll be doing this again next year. A, C, E. Do 2A. Yep. 3A. 3B. Sorry. 3A, 3C, 3E. I'll copy and paste this and I'll put this on Compass, okay, once the lesson is done. Yeah, for exercise 3G. I've already picked out the questions that I'd like you to complete for homework. See, this is a part of an extended response. This was in 2018, so this was the exam 3 years ago. Notice they give you a graph here. Then they tell you to answer a couple of things, find the median. That's another skill. You can skip that one. Then they give you the formula here. So that's the equation of the least squares regression line. Then they ask you what the response variable is. Okay, so we know how to do that. Then it asks you to predict. So it's a bit of substitution. Then in this particular question, we haven't done residual values, so we can skip that out on that one. So I still need to kind of like cross them out. There you go. The value of the correlation coefficient is 0.92. What is the percentage of variation in the evening congestion? So that's the idea from the question. in the morning congestion. So round your answer to the nearest. So that's a question right there in the exam, in year 12, that asks you. Okay? So what I want you to capture is the idea. You can see that it asks you at the end of the question. Usually these questions about R square appears at the end. Yeah. This is asking you to interpret the slope and also the intercept as well. So these two questions, it's jumping. B and C, it asks you to have a look at their formula. So this is all the skills that we've done. It's just that they've dressed it up differently. They're talking about a different story, but the underlying ideas, the mathematics behind it is still the same. Okay, so what I'm going to do is I'm going to continue sharing the screen here. And what we're going to do now, so that's R squared down. We've ticked off one of our learning intentions. The next one is the regression line, okay? So in chapter 4, that's 4B. Whoops. So write a title, exercise 4B. And for this one here, we're going to use our CAS to do it. All right. Now it does say warning here. If you do not correctly decide the explanatory variable, which will be your horizontal, remember E, capital E, for your explanatory variable, that's the horizontal line, and your response variable, capital R, which is your vertical line. If you don't correctly identify them and you start calculating the least squares regression line, you may get the wrong answer. So you have to be careful. The first step is to know which one is your explanatory variable and your response variable. Okay. Now they give us these values here. These are unfamiliar, right? Except for this one. We know this one. That's the correlation coefficient. And you'll come across this next year again, like the exact same variables, because this is coming from the Year 12 textbook. Okay. I'll also show you on your notes as well, or from the Year 12 exam, that you'll be using this formula here, because you can identify that there was an X bar, a Y bar, SY, SX, and the R as well. Okay, so keep those in mind. I'll keep this formula in mind. In fact, I might copy it and paste it into the notes, which I already have done this in our other lesson, but now we're going to apply that knowledge. So let's say they give us all that information. Now it says use the formula to determine the equation of the least squares regression line. Remember, the least squares regression line is in the form of y equals a plus bx. All right, but we want to predict the weight and the height. Calculate the slope. The slope is b, intercept is a. Correct to two significant figures. 2. So Arafat, if we are talking about significant figures, do we want fixed or float?
Significant figures.
Yeah. If it was decimal places, which one is it? Fixed or float?
Fix.
Right. So what about two significant figures?
Two significant figures. Would be flow.
That's correct. So float 2. Okay. This is how they represent it on the CAS or online or on computers. Okay. Different language, same idea. Okay. We're just translating between the two. Now, what I'm going to do is I'm just going to steal this here, bring it over. To a separate document. So we can have a look and we can have some writing space. So, I'll grab this part here. Copy, paste. This is the formula on your formula sheet. So in year 12, you will get this for both exams. In exam 1 and exam 2. You get that sheet that I was showing you before. So if we're given this information here, we can use it. We want to find y equals a plus bx. What we need to find first is our a. And we also need to find our b. We know how to find our a. A, using our formulas, a is equal to y bar minus b bar, minus b times x bar, right? What does this bar mean though? What do these bars mean?
Average.
Yes. The average or the mean. So this is the average or the mean value of x. And this is the average or the mean value of all your y's. What does the S mean? Oops.
Standard deviation.
Yes. Standard deviation of x. Standard deviation of y. I've got one more variable, r. And we've been covering that. That's our correlation coefficient. Okay, so that's the understanding. That's the theory behind it, if you want to understand what you're looking at. But otherwise, you've got one formula here. You've got another formula B, Sy over Sx. And you just need to substitute. Okay? And you'll be able to find it. So if you want to set this up manually by hand, you would find B first. So we know what our R is. It's 0.8502 times Sy at the top here, 7.594, divided by Sx, which is 7.444. But that looks so messy to type in, yeah? Let me show you how to do this on the CAS so it's done a bit more efficiently. So I'm going to show you the CAS now. Add a calculator. At the beginning in our question, we had all of the variables laid out to us, yeah? So I want to write I want to write x bar, but there's no x bar. So I'm just going to write x mean, so xm. We can define this or store a value for it, or we can use define, yeah? So actions, menu 1, xm, that's grouped as 1 bit, okay? That's 173.3. So I'm just looking at the book or the question at the moment. If you can type this in together with me, that would be fantastic as well. So open up a calculator and type this in as well. Because remember, in the exam, in the test, whatever you're doing in further maths or in general maths, you are enabled to use a calculator. So you may as well make use of it. Okay, and we've got one more. R equals to 0.8502. So you get all the hard part out of the way by typing and defining all of them. Now we know how to find our B value. B was equal to R, and notice how the R goes bold because we've already got a number for it. Times, it was the fraction sy over s. Notice if I just type s by itself, it doesn't go bold, but when I type sx, it goes bold. And press enter. So b was our slope, wasn't it? So that just gave us our slope. So it takes a while to set up, but once you got the setup, to get your answer, it's a lot cleaner. It's a lot easier to look at as well. Okay, if you typed it in correctly. You can also find out what A is. Now, once we've got B, maybe we should save it as B, yeah? So define. Now I want this part, yeah? So I just press up, I press enter, and it's done. So if I press B now, notice how B comes up. The other part was to find A, which was our intercept, yeah? We know what that was equal to. Y bar, which was ym. We wrote it as ym here, yeah? And xm. Minus B times the mean of your x, so xm. Press enter. Notice how it gives you your A value. So I'm just going to define that. Menu 1, and grab that number, define it. So it was two parts. One was typing in and defining your values. I'll copy and paste that into the notes. And part two was substituting and typing in your formulas. So I'll share the screen again now for the iPad. So can I just get a show of thumbs up or thumbs down if this process makes sense? Okay. It's maths becomes more bearable when you just have the calculator doing all the heavy lifting. All you're concerned about is just trying to put it in to get your answer, okay? And in year 12, these questions here would only be worth 2 marks. So save your brain power for bigger questions. Okay. So what we ended up getting for our y equals a plus bx was y. Well, what was our y if we have a look at our question? What was our y? You type in the chat if you want. Weights. Yes, correct. What was our x variable? Heights. Okay. So over down at the bottom here, instead of writing y, we write weight or weight. What's our a value?
$84.8586.
Is it just 84?
I said the decimals. I don't know if you heard. 84.8586.
Yeah,
I
so
think my
just
mic
take,
cut out. So
are we happy with that 84? What are you looking at? Looking at this part, yeah? Are you reading it properly? Thanks, Danny. Can't forget the
negative.
negative. Yeah, there's a negative right there, yeah?
Oopsie.
Plus our b, 0.867332. Now what's between the b and the x? Times. So make sure you write times. And our x was the height. Have we answered the question properly here? Looks a bit tacky, yeah? Doesn't look very nice. What was the condition here? Two sig fig. Thank you, Daniel. So we need to change this to two significant figures. So let's rewrite weight equals to negative. All right, how many significant figures if we pick two? Can you type it in the chat, please? For this first value here. Two significant figures. Because you could do this on the calculator, but if you know how to do it by hand, it's actually a lot faster. Yeah, correct, Forrest. You're just missing that negative on the A. Correct, Danny? Two significant figures. So two significant figures. Here's the first one, the 8. I might highlight this one. And the 4 is our second significant figure. But because the value after is an 8, this means we need to round up to a 5. So rounding. For the second one, 0. If we start with a 0, that's not a significant figure. The 8 is a significant figure. That's our first one. Next one is 6. That's our second significant figure. However, we have to consider rounding. Since this is a 7, that's greater, it's 5 or greater, so we have to round up. So the 6 goes up, so 0.8. Instead of writing 6, It has to round up to a 7. There you go. That's correct, Foss. You have to round it up. So can I just get a show of hands if this makes sense? So what did we do? We used our CAS to find our A and B. So that's what we did here. Use CAS to find your A, which is your intercept. And your B, which is a slope. You write the formula, which was on your cheat sheet. Substitute not just the numbers, but you have to substitute the ideas as well, okay, for X and Y. And you have to round. Okay, so 4 clear steps there. 1, 2, 3, 4. Okay. We could do this on the CAS if we had data. We could have just gone to the graph and just gone menu or analyze it to find your A value and your B value. But this is how you calculate your A and your B by hand, or still by CAS. But it just depends on the information that they gave you at the start. In this case here, they gave us this piece of information at the start here. So definitely something to take into consideration. Okay. So see this step here? If we were given data points, in our previous lesson, we learned how to do that using the graph. We analyze the regression line and we go show A plus BX. Notice there, it gave us the values. Okay. You can find the coefficient of determination as well. That's just the other calculator. For this particular exercise here, I'll give you 3 questions. Okay. Make sure you use your CAS. All right, I'm going to put these questions up on Compass now. So I'm going to stop sharing. And what I'd like you to do is begin looking at doing some work. Sorry?
You're still recording?